And now we will talk about what the self-model theory, what this would like, how it would look like if it would be interpreted from NARS theory. In NARS, we don't have such things as self-models. Instead, we have something which we call self-symbol, which is, like we will see, as a term with very specific properties. But at first, I need to talk about the knowledge representation. So there can be terms in NARS, and terms can be composed to compound terms to denote, for example, yellow bird. This example I gave already in the last presentation. So compound terms can let the system describe certain things by composing other terms together. And now we will get to one very important aspect, namely that the meaning of a statement is never inherent in the statement itself, but in the relationship to other statements. So the entire meaning of a statement in NARS can only be judged according to the past experience of the system. And because of insufficient knowledge and resource, this is usually just a part of the past experience. So in NARS, when we talk about the meaning of a term, we talk about the context, the entire context the term appears in, and on conceptual level, we say the meaning of a concept is determined by the concepts it's related to. So it's never the concept alone which carries the meaning, it's always the relationship to all the other concepts which it's linked to. And this is very fluid. In every reasoning step, the meaning can change. So this is a very fluid notion. And for this, in order to represent the self-model, it's the same like with all other terms. They get the meaning by the context they are used in. So it's the same for the self-symbol. It gets the meaning by the context it's used in. But like we will see, it's the way when it's used which makes this symbol, this term special. Namely, the first idea is that the parts of meaning of self, the way you represent yourself, can be constructed by the observations of own properties and actions. So, for example, I could do a certain action, I could go through the door, and I could say, I am the one who is going through the door. Or I could say, I am the one who currently is presenting this presentation. I could say I'm the one who is hungry. It's the relationship this self-term has with other terms which create its meaning. So the entire context, and this context is very fluid and naturally context-dependent. So this was this example with associating self with properties. And here we have an example which shows how we represent actions in order in such a way that in each argument, each action or each operation in the system has an argument which denotes self. So this way the system, the self symbol is present in every action the system takes. So it becomes part of the so the context of this self-symbol grows and grows, and the meaning grows with it. And here we see the structural way how we represent this. We start with the system eats an apple. This means for the system itself it's an apple. This has a structural representation as this, and this can be transformed according to the Nell rules, which says self is a special case of the things which eat an apple.
So how would the self-node get formed in the first place?
Whenever the system executes an operation, the self term is added. So it's always an argument of an operation. This way it always becomes so the semantic context of this self term always grows with every.
That does seem very different from a baby with a body, right? I mean, you feel like a young baby starts waving around its arms and legs and stuff, and then after a while it learns that it has control over these movements, and it doesn't have control over what the mattress or its mother does, right? So it seems like in a young human, there's no like self-neuron or something, right? It's more a learned distributed representation of some kind that comes out of understanding of the body and the learning to control the body, which a baby can't do well, somehow comes along with building a model of what the body is and the associated thoughts. So I wonder what are the consequences of building in a self-node like that as opposed to having a sort of cognitive perceptual action assembly representing the self.
I understand your concern about that it doesn't look natural on first look, but this way the self symbol can always be used by the system in reasoning. So this means the system can draw analogies and so on, which it would else not be able to make. For example.
I'm not sure. I mean, even within NARS, if you connect NARS to perceptual primitives and to actuators, right? Then NARS, in theory, if the reasoning, if the logic worked properly, NARS could itself learn this sort of distributed representation, which explains sort of the coordination between sensation and action in the course of controlling a body, right? So I mean, of course, it's simpler to write down examples this way, but it seems like even within a logic system framework, it wouldn't have to be done this way.
I understand. Yes, I also think that this self-representation could be possible to emerge in other ways, for example, through feedback over the environment. So in this respect, I totally agree, but by adding this self-term, it makes it significantly easier for the system to associate itself with certain properties and actions it takes.
I got a question in similar somehow. Are there several of these self-model layers that NARS is able to represent? I mean, these are formular, but I think you were talking about several layers. Is that right?
I'm not sure. Are you talking about the
the physical layer or meta representing the self in an action part?
Yes. To this I will come to the relationship to the self models, like you proposed them. To this I will come. Just in NARS we don't have directly building blocks like this, but instead we have this general language, and all these different aspects of self-models can come by inference, like shown with this example, that it represents itself as being a special case of something which eats an apple. So there can also be things derived. For example, if the system eats an apple and then it is satisfied, temporal induction will kick in. So eating an apple from this follows self-satisfied to a certain degree. And this is important. Nearly running out of current. Okay, and this way it can create things which we will see are very related to the self-models. This is also what he meant before, that that the null logic is general enough to represent these things which in his models were scene-based reasoning. So this is in NARS just a special case where there's certain background knowledge about scenes, and everything can be represented with this general null logic. So now we're coming to a last block before I will clear the relation to the self-models, namely introspective event and operators. For example, the system has events which will reveal or reflect internal processes which would else be invisible to reasoning. So these introspective events play the role to reveal this to the reasoning process. Also, there are introspective operators which are here to influence the system. For example, the system could say in its decision making to consider a certain concept in order to change its own attention. And here we have the relation to the self-models, namely it allows the introspective events and operators allows the system to reason, for example, about its own pursued course, which is similar like the intention and goal self-models, and to reflect the desire value of a concept, for example. Also allowing the system to reason about introspective events, like how busy the system is, how satisfied, and so on, can be reflected so that it's available for the system to reason about. But this is very related to the emotional self-model, and yes, so it's not quite clear for us which internal processes really need to be reflected so that the system can do reasoning about. This is a question we will better answer in the future, but what we know, it's a very important aspect of the way we ourselves think, that we are able to reason about our thoughts, to do introspective inference and decision making in our own. Thanks for your attention.